Hello everyone, it's me Gopi Krishna here to introduce a new topic to all of you, which is content based image retrieval. We have been learning about text based information retrieval so far. So let's have a look at what is CBIR. I mean, we have used it all the time, probably without even thinking or knowing about it, right? You know, that magic that lets you search for a picture using another picture instead of trying to type out a bunch of words. Do you remember that? Well, today we are pulling back the curtain of technology, which is called the CBIR, content based image retrieval. So, I mean, we have totally been there, right? Like, you've got this perfect picture stuck in your head. Maybe it's a very specific shade of a sunset, or a cool style of a building, or that weird bird that you saw on a vacation. But then you try to describe it to a search engine. Oof, that's a big task. It's just that impossible. A total dead end. And that frustration, it's have been there. So that is exactly the problem CBIR was designed to fix. Sounds awesome, right? So let's talk about the problem with words. For the longest time, the only way to find an image outline was by using keywords and tags. We called what we call the text-based information retrieval or text-based retrieval. So, but this whole approach, it's got a really big fundamental flaw built right in it. So let's have a look at that. The old way depended actually on a person. Let's take it as a person, a human being to manually tag every single image. Think about that. It's pretty slow, it's expensive, and honestly, it's super subjective. Yeah, right. An image can be perceived in a different way by a different individual. So, what one person calls gloomy, someone else might see as serene. Content based search, on the other hand, just sidesteps that whole human messiness. It goes straight to the source and analyzes the image pixels directly. Sounds awesome. So, what do we actually do? Or what's the real issue? So, when you search with keywords, you're not actually searching the picture. You're searching someone else's description. Sounds relatable or understandable. So you're totally limited by their words, their perception. And this whole problem leads us to a really important idea in computer vision. And what do we call that? Hell yeah, it's the semantic gap. And it's the gaping chasm really between how we humans see a photo, with all the context, the emotion, the meaning, and how a computer sees it. Computer just sees it as a grid of colored dots. So we might look at a picture and see a lonely boat at sunset, right? The computer just sees a whole lot of dark blue pixels or orange pixels or whatever that is. So the big question is, how do we possibly bridge that gap? Well, this is where content based image retrieval comes into the picture. It's a much more elegant and powerful way to find what you're looking for. CBIR, which you might also hear called as Cubic from an old IBM system, completely flips the script. Instead of making us translate picture into words, it teaches the computer to understand the language of pictures. Sounds cool. It basically teaches the computer, giving a point of view, visual, something like that. It looks at the actual stuff inside the images, the colors, the shapes, the textures to find that thing. The match. The whole process is actually pretty straightforward and it's pretty simple. It breaks down into three main steps. Let's take a look at it. We have the feature extraction. That's where the system breaks an image down into its basic visual parts. Similarity comparison, where it compares the data against a huge database of other images. Ranked results. Finally, you get your ranked results from the best match to the worst. Now, the way most of us use this is called the query by example or QBE. So it's simple. You give the system a picture, not bunch of words. It's basically the show don't tell. of searching for images, and it's way easier, to be honest. But how does a computer actually see a picture? How does it decide that one image is similar to the other or not? So that's where the real magic happens. And it all comes down to translation. So, here, the most important thing which we got to understand is every single image gets turned into a kind of numerical fingerprint. In the BIS, they call it a feature vector. So, feature vector is a numerical fingerprint. And it's basically just a long string of numbers that describes everything about that image's visual properties. And the system isn't thinking in terms of dogs or boats or whatever objects which you provide. Not yet, anyway. It's looking at what we call low level features. Think of these as, absolute building blocks of sight. For example, like things like mean colors or the shapes made by different edges, and yeah, and all the repeating patterns that create a texture. Like the grain in the wood, blades of grass, etc. And these measurements can get pretty clever, to be honest. And take color, for instance. The system doesn't just count the blue pixels. No, it uses a statistical method called color moments to figure out stuff like the average color and how much the colors vary across the image. This gives it a much richer, more accurate color profile to work with. So, next. So, first, let's have a small recap. Every image in the database has its own numerical fingerprint, right? That feature vector we talked about. So, what happens when you upload your picture? How does the system measure which of those million fingerprints is the closest match to yours? For that, we use a simple but powerful technique. Well, it uses a concept from math, and the most common one is called the Euclidean distance. The easiest way to think about it is like, a ruler, like the distance, just the distance. It's measuring the straight line distance between the numbers in your images, fingerprints, and the numbers of every other image in the database. The smaller the distance, the more similar the images are, and vice versa. Simple as it. Let's look at a really good example. Or let's take as a simple example. I mean, say your picture is a forest. We have taken a picture as a forest, or like we have a forest. Now let's compare it to two other pictures. Let one be a bright blue sky. And based on the distance, let's say the math is telling you it has to be 158. And there's another image picture of a forest, and the distance is only 14. So the system knows just from the numbers that the second forest is much better. It's all just plain math, simple maths. But what happens if those first results aren't quite what you wanted? Well, this is where things get really cool because the system can actually learn from you. Sounds great. This process is called the relevance feedback, and it's exactly what it sounds like. You basically become the teacher. The system gives you its best guess and you tell it, yep, that's the one. Or no, no, not that one. The system then listens, takes your feedback, and creates the next adjusts its strategy. It looks at all the pictures you marked relevant and tries to figure out what they have in common. Maybe it notices they all have a similar rough texture, for instance. So it learns, okay, for this search, texture is way more important than color. Then it refines the search and tries again, getting smarter and closer to what you want with every single click. And look, this isn't just a concept from a research lab or something. This technology is everywhere, to be honest. It's built into the tools, and I use literally it. I literally use it every single day. Coming to the history of it, like the idea has been around for a pretty while, like long back. The term was actually coined back in 1992. Just a few years later, in 95, IBM had one of the big commercial systems, Cubic. And then fast forward to 2008, Google took these ideas and scaled them up massively with its visual rank algorithm, as we know. And that's really what brought these reverse image searches to the rest of us. Coming to applications, doctors are using it to compare medical scans to help with diagnosis. It's the foundation for a lot of facial recognition used in crime preventions as well. Art historians, commerce app, all these places. Like, I mean, if you take a snap of a shirt picture and to find something like it, yep, that's where CBIR is at work. And by turning pictures into numbers, CBIR started to build the bridge across the semantic gap, which we discussed about. It lets us communicate our visual ideas directly to a machine. And I think that's the real takeaway here. We are not just teaching computers how to read text anymore, we are teaching them how to see, which really just leaves us one big question to think about. What's the next huge gap which communication the technology is going to solve? And yeah, I believe as a complete beginner to CBIR, I have covered all the pretty basics one would require. And I hope it was good, engaging, and happy to connect with you all. I'll provide the resources as links below. And thank you for joining. Thanks a lot. Bye bye.